Ya, kita tengok untuk hari ini computational thinking bab yang ketiga lah, iaitu abstraction. Abstraction ni macam yang kamu dah tengok minggu lepas. Abstraction ni adalah proses untuk kita kurangkan complexity dengan menggunakan beberapa approach by identifying and focusing on essential features or characteristic lah. Sama ada sistem, problem ataupun objek lah. And then kita we also ignoring the details that are not relevant to the current task or context lah. Jadi kita ignoring ataupun kita hiding details tu. Contohnya macam kita nak masak lah. Kita nak masak apa? Contohnya kita nak masak nasi ayam lah. Okay, yang pertama sekali kita beli beras dengan ayam lah. Okay, detail ayam tu macam mana ayam tu datang daripada mana kita tak perlu tahu lah. Ke kamu ambil tahu ke ayam tu datang daripada mana, berat dia berapa kilo, ayam tu ayam betina ke ayam jantan ke kamu ambil tahu juga?
Tak.
Yang penting kamu makan je kan. Makan, yang penting kamu kenyang dan kamu makan, tu je lah. Dan yang paling penting harganya murah lah. Okay. Okay, boleh ke? Boleh faham ke?
Boleh.
Tu je, mesti kamu nak tidur ni. Okay, kemudian it also involves the process proses untuk kita identifying tu kena simplify and generalize representation of the original concept lah. Jadi original concept yang kita ada, contohnya kita nak to find connection and commonalities. Kita nak buat kita nak identify, kita kena tahu dia punya connection dan commonalities lah. Common features dia. Apa common features yang boleh kita dapati lah. Kemudian kita perlu tahu juga dia punya karakteristik lah. Karakteristik untuk identify dan fokus features dia, iaitu quality, feature or quality yang that help to define or to identify something lah. Maksudnya sekarang ni bila kita nak kenal, kita kena tahu juga dia punya features dia dan dia punya quality dia, sama ada boleh solve problem ataupun tidak lah. Okay, and then next, the third paragraph, abstraction is the key concept in computer science, mathematics and many other fields lah. And it commonly used to manage complexity, create general solution and facilitate communication and understanding. Ini lebih kepada dia punya advantages lah. Okay, advantages dia adalah untuk kita uruskan complexity ni. Kemudian kita create general solution. We are looking for the generic solution that focusing on the quality also, but we encapsulate the task lah. Okay, encapsulate the detail of the task lah. Okay, yang itu yang penting lah. Okay, yang ni yang seterusnya, yang ni adalah explanation daripada 3 komponen yang saya nyatakan tadi. Reducing complexity, abstraction allows to dealing with a complex system by hiding low level details. Low level detail ni contohnya macam kalau kamu nak beli handphone handphone tu, bila kamu beli iPhone, kamu ada ada nak selidik kat dia punya komponen tu datang daripada mana, daripada China ke, daripada India ke. Tak ada kan. Yang penting dia punya function kan. Ada bila kamu nak beli iPhone, kamu tanya salesman tu lah, iPhone ni dia punya microchip dia 3 nanometer ke 4 nanometer ke, panas tak? Ada kamu tanya macam tu dekat salesman? Tak ada kan. Jadi kamu bila nak beli tu, kalau brand mahal ni kamu tak tanya, kamu beli je. Kalau kamu banyak tanya, salesman pun dia kata kamu ni macam tak ada duit je. Itu contoh lah. Kemudian hiding unimportant details lah. Contohnya kat sini kita tengok not relevant to in particular context. Suppress maksudnya dia hide, dia encapsulate yang tak penting lah. Contoh macam internal function of software module is hidden to simplify its usage lah. Contoh macam kamu beli komputer and then dia ada semualah Microsoft Office, Photoshop dan sebagainya. Tapi dia punya modul macam mana cara nak guna tu biasanya dia akan hide, dia akan simpan lah. Okay, so in summary, we can say that abstraction is a bigger picture of thinking lah. Characteristic capture, key traits or key features, and detail provide granular specific lah. It's basically focusing on details that are discarded to build some simplified model that highlight the key characteristics. Okay, ada soalan? Kalau ada soalan boleh tanya lah. Syam okey ke Syam? Ahmad Isyam okey ke?
Okey aja.
Nadia? Nadia boleh ke? Nadia? Nur Nadia?
Saya ke doktor?
Nur Nadia.
Saya okey je.
Okay. Zuleha okey? Nur Zuleha? Nadira tadi on the way dalam bas, dia tak dengar kot.
Saya ada doktor tunggu bas.
Tengah apa? Tengah basuh baju? Kamu tengah apa? Tengah basuh baju ke?
Tengah tunggu bas.
Tunggu bas. Ingatkan tengah basuh baju sementara tunggu bas tu.
Tak.
Okay, this one is important because in the exam I will ask about what is the important details, what is unimportant details or complex system in the scope of abstractions. Okay, and then it also building a hierarchical models that broken down multiple abstraction layers. This one is important because each layer is hiding or encapsulate the lower layer. The higher layer deal with the bigger concept built on the lower level abstraction. So this allows the hierarchical or modular design lah. Yang ini penting sebab karakteristik untuk abstraction ni adalah untuk bridge the abstraction and details. Abstraction is the characteristic to help bridging the abstraction and details. It also defining the traits that enable us to categorize and make sense of some things. That's why point number 2, it will also improve the understanding. Abstraction help focus on what something does rather than how it is implemented. Okay, so it will improve the understanding of the complex system by reducing some element to simplify the conceptual model. Okay, ini yang penting bila kita improve kita punya kefahaman tu, yang penting adalah dia punya sifat ataupun karakteristik untuk abstraction ni adalah untuk hubungkan antara faktor umum dengan faktor yang detail lah. Faktor detail ni faktor apa? Faktor yang lebih detail lah. Okay, lebih lengkap. Okay, and then the important is to enabling the reusability. Abstracted component can be used or reused across the multiple contexts due to well-defined concept. Yang ni penting sebab setiap kali kita nak gunakan, kita kena we need to reuse back the component and importantly the conceptual interface hiding internal complexity lah. This enhances the software reusability. Okay, nanti kita akan tengok contoh software reusability. Okay, software reusability is an important concept in software engineering and also software development because it refers to the ability of the system to use existing software component again and again in other project or system lah. Dia punya kelebihan dia adalah the advantages is to save time, resources and cost compared to building or develop from scratch element from scratch. Okay, and then also for the reusability, kalau kita tengok dia ada beberapa challenges lah. The first challenges that when you use the reusability is to increase the initial design time, overhead from generalizing functionality and managing dependencies. Yang ni adalah dia punya dia punya critical factors lah. How abstraction is applied in the problem solving. Okay, driving car. Okay, driving car ni kalau Alia ada? Nur Alia?
Ya, doktor.
Kalau yang macam ni macam mana? Abstraction kalau kita tengah bawa kereta, apa yang kita hiding kan? Apa yang kita sembunyikan?
Masukkan kunci, doktor.
Kunci kita kena tahu lah. Apa kat luar tengah membeli
Kena
tak?
tahu. Tak, kita orang tadi tengah tunggu bas nak pergi kelas. Pasal kita orang stay dekat cafe, dekat area sini.
Nak makan lah tu. Patut nampak makanannya. Okay, driving car ni dia detail yang kita hide adalah don't think about the engineering behind the engine lah. Okay. This one yang kita tak tengok. Kalau kamu nak makan bila kamu order, contohnya order nasi ayam, kamu ada tanya peniaga tu tak, nasi tu beras apa, beli kat mana, mahal ke murah, ada tanya tak? Ada? Hilang dah tengah makan. Okay, Izzat ada Izzat? Amirul, Izzat? Izzat ada? Amirul, Izzat?
Ya, saya. Doktor?
Kat mana, kat rumah?
Saya kat library, doktor.
Tak boleh cakap kuat tengah makan je.
Kat bawah.
Jadi kalau kita bawa kereta ni, selain daripada enjin, apa lagi yang kita abaikan? Yang kita tak fikir?
Selalunya angin tayar, doktor.
Tayar kena sebab safety. Okay, kita tak fikir contohnya macam mirror. Mirror tu macam mana dia buat, macam mana engineering behind the mirror, we don't care. We don't care and we don't want to know lah. Contohnya macam dia punya doors, material, datang daripada mana. Kita tak search in details lah. Maksudnya kita encapsulate behind the very important key point Jadi itu yang paling penting. Maksudnya kita encapsulate certain point which mean that we generalize key point Okay, boleh ke? Siapa ni? Alia. Alia boleh ke? Alia Izzah. Izzah boleh ke?
Boleh, doktor.
Dah buat apa tu?
Tengah menulis.
Dia apa? Surat cinta?
Tak adalah tu, nota.
Ya ke? Dengan bunyi ni? Bunyi horn tadi?
Bunyi apa, doktor?
Bunyi horn. Dia
Dekat bilik.
nampak dah horn lah tu. Ajak makan.
Tak ada.
Okay. Okay, this one is come from the slide before this, the breaking down the complex car system into more manageable subsystem lah. For example, we don't care how the engine was made, the transmission, steering, brakes, electrical, and etc. This divide the problem space. Problem space basically we focusing on the details of the generic problem first, and then we go by the specific problems. Focus only the essential function of each subsystem, hiding internal complexity lah. For example, if you go by the laptop or desktop, the first thing first, you want to know or you want to demand is to you have a tendency to go online classes, okay, and then to go to do the writing stuff and so on lah. This one is very important lah. Okay, to breaking down from the generic to specific lah. And then number 3 is to identify the common pattern and core interfaces lah between the subsystem. This one is same like the slide before this, is to bridging to help the bridge abstraction and also for the details. Okay, and then represent the abstract interaction between subsystem with simplified model. Okay, this one I have explained. And then different abstract system optimized for goal like fuel efficiency, safety and cost and etc. This provide alternative solution. This one is important but not so important compared to the engine itself. Okay, and then reuse proven reliable abstracted solution for sub problem like brake, fuel injection etc. Adapting them as necessary. This one is the subset from the superset. Superset like engine, like transmission. But this one also very important, very vital to the engine component and system. Okay. Then refine the abstract model by iteratively incorporating more details. This one is the we call it as reusability. Reusability by iterating some process and also some details. And then modularizing the abstract model into well-defined function WDF that can be independently built and tested. Lastly, communicate the emerging design to stakeholder using abstract system diagram and specification, not implementation details, because some of the stakeholder might copy your own implementation if you show them the implementation details. This one is very important. Of course, if you want to highlight or demonstrate your system, the first thing first, you highlight the functionalities. But uncommonly when the developer shows up the implementation details like coding code and so on lah. Okay, this one is the abstraction. This one is the key, the road in London, I think. London. The most importantly is when the road was highlighted in red. This one is busy road. The yellow is the unbusy but still congested. And the green one is the freeway flow of traffic lah. Okay, and as you can see, lots of road in London is classified as red. Okay, this is how you classify the problem from the generic to specific problem. Sharifah, okey ke Sharifah? Sharifah,
Okey doktor.
boleh ke? Diam dah.
Boleh.
Sharifah kat mana?
Dekat depan lab.
Depan lab? Oh, datang juga?
Saya ada kelas pagi tadi.
Dah tak balik dah?
Ya.
Kenapa tak bagi tahu tadi? Ramai yang dah ada kat lab. Selain daripada Sharifah, siapa lagi yang ada kat lab?
Ada Aiza.
Oh, dia juga. Tak apalah, kamu tunggu je lah jaga lab Jaga lab sampai pukul 4. Okay, and then this abstraction goes samely to the rail station. In somehow in KL you can see this one is the monorail. Monorail in London also they call it as the what system? What the name of the system of London Railway? National Rail. National Rail. National Rail of London UK trains. Okay. Okay, London Rail. This one, as you can see, it's being highlighted in green, in red, okay, and yellow. This one is the available route that you can take from point A to point B. You can see lots of railways incorporated the relationship, okay, with one destination to another destination. Okay. Okay. How you implemented the abstraction in the railways? Mana kita nak associatekan railways dengan abstraction? Boleh tolong jawab? Apa ni? Aiza tadi ada Aiza?
Ada doktor.
Macam mana kamu nak kaitkan railway dengan abstraction? Apa dia punya sangkutan dia, apa dia punya association dia? Kamu tengah makan ke, Aiza?
Tengah minum.
Oh, patut tak boleh jawab. Macam mana tu? Apa kaitannya railways ni dengan abstraction? Aiza?
Railways tu dengan?
Railways ni dengan abstraction, apa kaitan dia? Ada kaitan tak? Ke tak ada kaitan?
Tak tahu.
Tak tahu, macam mana boleh tak tahu? Kamu ambil kelas saya. Kamu FKMT kan? Nanti kena belanja saya minum baru kamu tahu Okay, railways ni basically it allows you to ignore the mechanical details of how the train will work. As a passenger, you only care about departure and also destination. Aiza, tutup microphone. Okay, similar to how abstraction simplify the code of usage. Same goes to the car. Okay, and then the tunnel and bridges also abstract away geographical complexity, just like the abstraction in code. It hide lower level complexity. The train passenger doesn't want to know about this. Okay, about the tunnel and bridges. And what they care about is only care about the departure and also the destination that they will go lah. Okay, the railway track is also an abstraction layer. It provides a simple, standardized and interfaces the rails, and also it will hide the underlying complexity of the travel, like the locomotive signals, the railroads, okay, the color, okay, the complexity of the railroads, the interchangeable part and so on lah. Okay, ada soalan lain ke? Syahrin Akmal ada?
Ada doktor.
Ada soalan ke? Setakat ni boleh faham ke?
InsyaAllah boleh doktor.
Ya ke? Kamu tengah makan juga ke?
Baru habis makan doktor.
Kamu makan dengan Aizah ke tadi?
Bukan.
Pecah rahsia. Makan dengan dia ya?
Dah doktor. Kita orang dekat KH.
Kat KL dengan siapa?
Dengan Aiman. Amirul Aiman.
Aiman bagi tahu saya tadi dia ada kat ni, kat fakulti.
Mana ada? Aiman lain ke doktor?
Kamu biar betul ni.
Betul lah doktor.
Okay.
Bukan saya bukan kamera doktor.
Apa?
Bagi nampak Aiman.
Okay. Okay, this one is problem solving by abstraction lah. Suppose we have asked to solve the equations A multiplied by Y and 4 plus B multiplied by Y and 2 plus C equal to 0. Then we want to substitute by X, we get the quadratic equations. So we know how to solve the quadratic equation by using abstraction lah. First, second, third lah. The step-by-step modularity, we can see that this one is the from the high level complexity to the low level complexity lah, by separating the main problems of the complexity lah. Okay, Joshua. Okay, ni burung apa ni? Penguin ke apa nama dia?
Burung dadak.
Apa? Orang hutan?
Burung dadak.
Burung dadak. Burung apa tu?
Burung dadak.
Burung dadak. Kalau dalam bahasa Inggeris burung apa?
Tidak tahu doktor.
Tak. Siapa yang tahu burung apa ni?
Atlantic Puffin.
Atlantik?
Puffin.
Apa tu? Dia nama dia Atlantik ni lah. Okay. Dia burung dekat Atlantik lah. Atlantic Puffin. Okay. Dia senang je. Kita kena ni lah. Kita kena scan guna Google Lens. Okay. Why we need to scan in the Google Lens? Because it classify and train the image and also compared to the existing image lah. Abstraction is identifying and extracting relevant information to define the main ideas lah. Okay, and then one object stand for many lah, and allow us to deal with the complexity and also the complexity of the skill lah. For example, be able to identify and filter out some details or ignore the details. For example, Bloom taxonomy, if you see the higher thinking order skill is from creating until the remembering. And then for the word, some of you like K-pop music lah. Okay, ada soalan? Do you have any question? Ada soalan ke? Okay, the images project this one is teachable machine later we see this one. Okay, the image project is using the teach model to classify using the webcam lah. Yang dekat depan dia tu apa tu? Depan dia ni Ainur Aisyah ni depan dia tu apa tu? Dog ke? Ke patungnya?
Saya ke? Anjing.
Lah tahulah anjing. Kenapa anjing tu tak ada mulut?
Patung-patung tu.
Apa dia? Sebab dia patung. Okey okey. Okay, jadi bila anjing ni kita apa? Kita paparkan dekat webcam, jadi dia me and plus the dogs, dia akan lebih tinggi lah compared to just me. Just me pun ada juga sebab gambar dia pun ada juga. Bila dia combinekan dua tu, classifier dia akan dapat detect dua-dua image sekali lah. Okay, teachable mission later we see this one. Okay, okay, to train the computer to recognize your own image and sound and also poses. Poses is the kamu punya pose lah. Okay. It enables building image, audio and pose a classification model by providing example of each class and then to teach the model. No programming or expertise is required. Okay. And then the user interface is interactive and also you can see the visual interfaces that allowing you to add training data, evaluate the result and also to export the model quickly lah. And then for this one is built-in model architecture include the mobile net for image classification, speech command for audio and post net for post detections lah. And then the model can be trained and tested right in the browser lah. Later we see this one in the browser. The model also can be exported as tensorflow.js in JavaScript packages and then be able to run on website or as TensorFlow type model for mobile applications lah. And then the limitation simplicity of built-in architecture and lack of flexibility compared to coding a model. Okay, this one is a problem solving approach. We have machine learning, training the data, learning machine learning and model. The input is new data. And as you can see in the graph, we come out with a prediction model. Okay, ada soalan ke? Okay, siapa ni? Zulfitri ada soalan ke? Zul?
Ya, Doktor.
Ada soalan ke? Kamu kat rumah ke?
Saya baru nak pergi balik rumah sebab hujan baru reda sikit.
Okay. Hati-hati Jangan dengar kuliah semasa atas motor. Tak digalakkan.
Ya, tak Doktor. Saya dalam kereta je.
Oh, ada kereta. Sorry lah. Boleh ke? Ada soalan ke? Tak ada?
Untuk yang training data tu dia lebih kepada AI saja ke Doktor?
Training data ni dia lebih kepada mathematical model lah. Kita sample data tu daripada ni tadilah, daripada image, videos and audio lah. Jadi kita cubalah yang ni. Okay, dia lebih kepada mathematical model lah, training data. Okay.
Alright, Doktor, boleh.
In order to achieve or to predict some prediction or decision without being explicitly programmed to do so, it also train the data. This one is training data lah. And then machine learning model continually to learn, improve and become more accurate as they expose to new data lah. That's why it is important to have a lots of data. We call it as a data set. Common machine learning model include regression, classification, clustering, dimensionality reduction, reinforcement, learning and neural networks. This one is common machine learning models. Popular algorithm include decision trees, random forest, key nearest neighbor, k-means, linear regression, logistic regression, etc. lah. And then major application include image recognition, natural language processing, NLP, forecasting, medical diagnosis, bioinformatics, fraud detection, and so on lah. Is the output of the predictions. And machine learning also intersects with statistical, probability, linear algebra, optimization problems. Okay, in summary, we can conclude that machine learning utilizes statistical technique and also algorithm to give computer system the ability to progressively improve and also learn from the data without being explicitly programmed step by step lah. This one is abstraction model lah. Okay, this one is define a system that can map the input and output lah. Okay, we go further. This one is the lung volume, actual lung volume, spirometer. Okay, what is spirometer? Okay, spirometer is apparatus or tools for measuring the volume of air inspired and expired by the lungs. This one is very critical apparatus or devices. Spirometer also measure the ventilation, the movement of the air into and out of the lungs, and then the some of the spirometer have digital measurement. They also identify two different types of abnormal ventilation patterns lah, obstructive and also restrictive. This one is the predicted lung volume, as you can see for neural fuzzy model. Neural fuzzy model. Okay, boleh ke?
Boleh.
Apa tu? Suara lembut je. Dia nak tidur dah tu. Okay, neural fuzzy is a modeling that divided into two areas. Linguistic fuzzy modeling, which focus on interpretability, mainly Mamdani model, and precise fuzzy modeling is focusing on accuracy. Mainly, we can call it as Takagi Sugino Kang model, TSK model. Okay, this one is to predict the lung volume, and then we have the sum, big sum here, and then it goes back again to learning algorithm. This one is the actual process lah. The device collecting the data from the patients. And then this one is machine learning. Okay, this one training data and machine learning. And this one is the input. This one is the process. And actual lung volume is the output. Okay, this one is machine learning in generic. Machine learning in generic. Machine learning is in the field of artificial intelligence that enables computer to learn and relearn, and also to improve the data from the experience. It collect the data set from the experiences without being explicitly programmed. Okay. As you can see, we have supervised learning and unsupervised learning. Okay, supervised learning, as you can see here, we have regression and classification. It's basically a category of machine learning algorithm that learn from label training data. Some of the key point about the supervised learning is the goal is to map the data into known output volume or values, learning and inferred function or pattern. This one is important. And then common supervised learning tasks include the classification, assigning the categories, and also regressions. You have regression. Okay. What is regression? Regression is to predicting the continuous values. Okay, for example, we have weather forecasting. Okay, for example, this evening is going to be raining. Okay, And then popular algorithm include linear regression, logistic regression, naive-based decision trees, and so on. After training on sufficient label example, the supervised model can take a new input data and predict accurate output values. The application involve any problem where historical training data is available to build a predictive model. So as you can see, classification, we can model some of the output. For example, image classification, identity, fraud detection, and so on. This one is based on the classification model. What is the advantage of supervised learning? The advantage is highly accurate model when training data is sufficient. So the basic important key factor here is the sufficient data and the ability to measure the optimized model to improve the performances. Okay, this one is very important also. And also we have some disadvantages. Okay, we have the contradict or disadvantages include requiring a large training data set. Of course, if you want to have a good output, you need a bigger data set, which can be expensive or impossible to obtain. For example, if you want to collect all the PNGK for all universities in Malaysia, I think it's quite impossible because we have a lot of students, millions of students studying at university right now. Okay, this one is supervised learning. Ada soalan ke? Kalau ada soalan boleh tanya. Isyamuddin, okay? Muhammad Isyamuddin boleh ke? Hilang dah?
Boleh Doktor.
Kamu tengah buat apa?
Tengah duduk dengan Doktor.
Okay. Rajin kamu. Okay, Nur Farhana ada ke? Nur Farhana? Nur Farah. Farah ada?
Ada doktor.
Kenapa? Ni berdengung suara. Kamu dekat dengan siapa?
Apa tu doktor?
Kamu dekat mana?
Dekat library.
Dekat library. Kenapa ramai sangat dekat library? Dah cantik library.
Kuat lain. Kalau dekat polis tak kuat lain.
Oh, okay. Okay, boleh ke? Boleh faham ke? Ke kamu menyampah kelas saya ni?
Dah lah doktor. Boleh.
Apa sikit-sikit yang menyampah? Okay, tak nak macam mana lah kamu pilih sebagai elektif? Okay, we go by unsupervised learning. What is unsupervised learning? Is the category of machine learning. Sama juga. Machine learning juga. That can be analyzed and draw interfaces from data set consisting of input data without label response, without concerning the details. The key characteristic of unsupervised learning, we have a model that used to discover hidden pattern, grouping, association, and structure with unlabeled data. Okay, we have unlabeled data. Okay, and then we have common unsupervised tasks, including clustering, anomaly detection, neural networks. Okay, and then auto encoders and so on. For the algorithms, we include the K-mean, DB-scan, principal component analysis, PCA, and so on. This one is unsupervised learning. Since the data given to unsupervised learning is unlabeled, the model itself must be infer the pattern and relationship. Because we can see the elicitation, feature of elicitation for the unsupervised learning. We need to monitor the pattern and also monitor the relationship. How we want to monitor, because they have no documented, undocumented algorithm. We should make some inferences. The goal is to compress the data by discovering unknown clusters. Unknown cluster or finding low dimensional representations. Okay, the inferences made by unsupervised model can highlight some relationship, features, and also the structure that we can previously see as unknown or difficult to comprehend. So this one, as you can see, dimensionality reduction. We have big data. We have meaningful compression. This one based on the inferences, not based on the structure abstraction, but based on the inferences abstraction. And then the inference for unsupervised learning is commonly used for exploratory data analysis to identify insight that can also lead to the new hypothesis and predictive model. The key application include customer segmentation, image compression, information retrieval, statistical model, and object recognition. This one is unsupervised learning. Okay, the drawback for the unsupervised learning is there are no objective right answers because we infer based on the logical thinking for unsupervised learning. Okay, and then the last one we have reinforcement learning. Reinforcement learning. Okay. Reinforcement learning basically is the machine learning approach based on rewarding or desired behavior and also we penalizing undesired one. Okay, for example, in reinforcement learning, an agent learns by interacting with environment and receiving feedback. For example, game for artificial intelligence. You can see in Roblox. Okay, the application include robotic, game playing, autonomous vehicle, resources management, logistic and control system. The goal here is range from maximizing profit to avoiding catastrophic outcome. Okay, for the reinforcement learning differ from supervised learning since correct input or output pairs are not presented. This one is here for the output. Okay, for the output for the reinforcement learning is no output. Okay. It differ from unsupervised learning since it actively optimizes a reward signal. In the model itself, they have the reward signal. Okay, what is the advantage of reinforcement learning? It includes suitability for online learning and real-time environment where feedback is continually generated. Okay, for example, after the class, you guys can also have some feedback. And also we have disadvantages include sample inefficiency and high resource requirement, high resources. Okay, this one real-time decision, robot navigation, learning tasks, skill acquisition and so on. In summary, reinforcement learning apply insight from behaviorist psychology to allow the agent to automatically determine optimal behavior within a specific context or environment. Okay, this one is reinforcement learning. Okay, how do I use it? This one is to gather, train and export. Okay, this one the image project. Okay, you can upload from the webcam. Okay, or you can upload from your devices. And then after that, you click the train model and you have some option advanced here. And then to preview, you can export the model. Okay, today objective or mission, try to make your own image classification model using different picture belongs to different category. Okay, okay, we open up the teachable. Okay, boleh nampak ke yang saya share ni?
Nampak tak?
Nampak.
Okay, yang
Nampak,
ni teachable. Boleh dengar suara ke?
Boleh.
Boleh.
People are training computers and creating machine learning models to explore all kinds of new ideas. New ways to interact.
Yes.
Yes.
to understand the world, to play, and experiment. But machine learning is pretty intimidating to get into. So we've been wondering, what if it wasn't? With Teachable Machine, we set out to make it easier for anyone to create machine learning models without needing to write any machine learning code. When it first launched in 2017, it allowed everyone to get a feeling for what machine learning is all about. But now, Teachable Machine puts the power of machine learning in your hands, allowing you to save your models and use them in your own projects.
So let's say you want to build a model to recognize you versus your dog. You just open up the site, record samples of you and samples of your dog. Click train, and you instantly have your own machine learning model, which you can use in your sites, apps, and more. You can upload your model to host it online, or download it to work entirely on device.
With Teachable Machine, you can create custom models for all sorts of things. Using images, audio, or even poses. Personalized machine learning models for the things that matter to you. And folks have already been trying it out, using Teachable Machine in their own experiments, solving problems in their communities, or even just at home. Start creating and see where your ideas take you at g.co/teachable machine.
Okay, dah habis dah. Okay, jadi Teachable Machine ni, jadi kalau kamu tengok Teachable Machine ni, boleh dengar ke suara saya?
Boleh, Doktor.
Boleh Doktor.
Okay, how can I use to teach it? Yang ni image semua kamu boleh try nanti dan kamu boleh tunjuk kat saya lah. Okay, for learning kita ada ethics semua lah, tweet dan sebagainya lah. Yang ni dia teach dia punya anjing kena buat banyak kali lah. Sama juga kalau kita buat dekat kita punya handphone kalau nak detect kita punya face okay, yang perempuan lah agaknya kalau telefon tu dia boleh ni, dia boleh bercakap agaknya tudung lah repair tudung berkali-kali lah baru baru ambil gambar Saya tadi masa nak pergi makan ada budak perempuan tu dia nak balik rasanya, nak balik ataupun nak pindah ke. Saya tengok banyak barang di atas motor. Lepas tu sempat lagi dia selfie kalau sekali tak apa rasa dia nak buat ni kot. Dia nak buat Teachable Machine kot. Dia ambil sampai 5-6 kali mungkin sebab tudung kot. Budak perempuan biasa macam tu ke? Ni Alia macam tu ke? Ambil 2-3 kali baru puas hati. Okay, setakat ni ada soalan ke? Boleh ke?
Boleh.